project proposes the enhancement of protection system for secret data communication through encrypted data concealment in encrypted images. To preserve an image quality during image recovery, reserving room approach is used to reserve space for embedding a privacy text messages. Here, chaos encryption is used to scramble an image except reserved space to make protection of image details using transmission. After an encryption of image, the encrypted secret data is hidden into the reserved coefficients using adaptive LSB replacement algorithm. Finally, image and hidden text will be recovered without any loss based same methods which are used at embedding stage. The technique used to encrypt the confidential data is unreadable form is based on difference expansion. The confidential data is embedded into the image using bit modification technique, and it leads to poor data hiding and has more distortion which degrades the image quality. In the proposed system, the proposed technique used to encrypt the image uses chaotic mapped based encryption. In the same way, confidential data is encrypted into unreadable form using discrete wavelet transform. After data encryption, the confidential data is embedded into the image pixel coefficient using adaptive LSB replacement. The technique will ensure secure information hiding with minimal distortion of host signal. Moreover, this technique contains an authentication stage to prevent unauthorized users from extracting the hidden information. The block diagram which depicts the encryption of the data hiding shows the block separation, lifting wavelet transform, detailed coefficient extraction, chaos encryption, data concealment where the chaos encryption of secret data and the image is being done. In the decryption part, the same is being recovered using the reverse process. Next is the lifting wavelet transform. This technique is used to research space for hiding data with minimum distortion. So the lifting wavelet transform divides the image into different subbands, high frequency and low frequency. High frequency contains the important information in the image, and the low frequency contains the important information in the image, and the high frequency contains the edge details, noise, and other unwanted part of the image. Thus, we choose low frequency for hiding of data. This block diagram shows the separation of high frequency and low frequency. Lifting wavelet transform can be implemented using the following formulas given in the step 1 and 2. This shows the input image, and the B channel of the image is being separated for making changes. Out of RBG, B channel is found to be most least sensitive to the changes made. Next image is the transformed image when we apply the LWT. Chaos encryption. Chaos encryption is what we are using for encrypting the data and the image. It is just the bit XOR operation between the image and the threshold function. The chaos encryption can be understood by this image encryption flow, where the chaotic sequence generation is being generated from x n plus 1 is equal to u into x of 1 minus x. After finding x n plus 1, the proper value for the threshold function I is being determined, which is then bit XOR with the input image. In the proposed system, the proposed technique used to encrypt the adaptive LSB embedding. Now we have data and the image encrypted. Thus, we have to combine both data and the image. For this, we are using adaptive LSB embedding. In this, the first bit of the message is being embedded into the LSB of the first pixel, and the second bit of the message is embedded into the second pixel. We can clearly understand the adaptive LSB using the algorithm flow. The first 3 bits of the message is going to be embedded into the image coefficient, which is the last 3 bits. Thus, after the LSB, the last 3 bits of the image will be replaced with the first 3 bits of the message. So the data extraction part goes with the reverse process of what we have done in the first beginning. First, the encrypted text is being recovered from the image, and then the text is being recovered from the image, and then the image is being decrypted. This shows the encrypted image and the recovered image. We can analyze the image quality using the performance analysis, where we find the mean square error, peak signal to noise ratio, and the correlation coefficient. Okay, the correlation coefficient gives how far the input image and the encrypted image are similar. That is given by the formula, and hence we also find the peak signal to noise ratio and mean square error to find how much error is being present. This shows the sample text encryption and the recovery of the process what we have carried out. We can see the elapsed time is only 7.7 seconds, and also very less correlation. The advantages are it has very less computational time, more security, and the data capacity is very high. It has a lot of applications in the research and medical processes. Thank you.